Welcome back everybody. Today we'll be looking at angles of tangent lines in polar coordinates. So our goal is to find the angle between the radial vector r and this tangent line to the path of motion. So in this case, the angle we're looking for is this angle right here, which I'm going to call phi. So like the previous derivations, what I'm going to do is actually look at how the radius changes along the path. So I'm going to take the first vector, which is going to be this vector right here, and then some time later or some change in angle later, the vector is going to be over here. So I denoted the initial position as r of theta, and then some time later the vector changes, and I'm going to define that new vector, or the second vector, as r of theta plus delta theta. So let's imagine that we keep this radius r of theta constant as it rotates along this path. So if r of theta was constant, what would happen is that this vector will follow this trajectory, which is a curved line. And now we could also look at what this means. So this vector right here, from this point where this blue dashed line touches the other vector, this vector really is just r of theta. So I'm going to define this length from the origin all the way to where the blue dashed line touches as r. So this is just the magnitude of r of theta. I'll write r of theta. And then this extra little bit right here is actually the change in the radial direction. So we're going to say this is the change in r. And again, as we defined prior in other videos, this is going to be an arc length. So we could define that as delta s. And then the relationship with delta s with the radius is simply going to be delta s equals the magnitude of r times the change in the angle. But what's special is this shape that is left over right here. It almost looks like a right triangle if you look at it very closely. So if we let delta s or delta theta go to 0, this angle or this arc is going to be more and more straight, and it's also going to be more and more perpendicular to the radius or the radial vector. So what we're going to get is this right triangle as delta s approaches 0, or delta theta approaches 0. So if we let delta s approach 0, this is going to be delta s, and this right here is going to be the change in the radial direction. So what we can do is actually define this angle as phi. Now that we have that, we can define tangent phi as simply the change in s, or the change in the arc length, which is this blue line, divided by the change in r. And we also know what the arc length is in terms of the angle. So this is going to be the magnitude of r times the change in theta divided by the change in r. So if we take a limit, we could say the limit as delta theta or delta r goes to 0, we could say that this is going to equal r of theta, the magnitude, times delta theta over delta r, and this is going to be r of theta d theta dr. But since we're going to have an equation of r with respect to theta, so this is going to be, for example, we could say some constant alpha times cosine of theta. So r is going to be a function of theta. What we can actually do is rewrite this so that when we take the derivative of r with respect to theta, we don't have to do the inverse of this. So what we can say is that this is going to equal r of theta, the magnitude, divided by dr d theta. Or in other notations, we could just say this is going to be r divided by dr d theta. So the main equation is that tangent phi equals r divided by dr d theta. That is the equation to find the angle between the radial vector and the tangent line. So there's a natural question that arises. How do you know that phi is this angle right here and not this angle right here? And to be honest, that's a very good question, and I'm going to explain that in the next video because I think that is a topic for itself. But the main point that we got from this video is that we could define the angle with respect to the tangent line and the radius in terms of the function of r with respect to theta and its derivative with respect to theta. That is the main thing to get from this video. And again, this is going to be useful because sometimes we're going to define particles and they're going to be defined by some function of theta, and we're going to need to know that tangent line to find these angles of forces and so forth. So hopefully this helped you. In the next video, we'll talk a little bit more about the angle and what it means. So with that being said, I'll see you in the next video.